In this question, we're told that A, B, C and D are 4 points on a circle. AEC and DEB are straight lines, and we're told that triangle AED is an equilateral triangle. We need to prove that triangle ABC is congruent to triangle DCB. You can see that triangle ABC is highlighted in orange, and triangle DCB is highlighted in blue. Now, to prove that two triangles are congruent, we need to know what congruent means. And so two triangles are congruent if they have the same size and the same shape. Now, there are 4 different criteria that can be used in order to prove that two triangles are congruent. Now, these criteria are SSS, ASA, SAS, and RHS. Now, for two triangles to meet the SSS criteria, they have 3 identical sides. To meet the ASA criteria, the two triangles must share 2 identical angles and an identical side in between those 2 angles. To meet the SAS criteria, the two triangles must share 2 identical sides and an identical angle in between those 2 sides. And the final criteria is RHS, which means that if 2 right-angled triangles are congruent, they'd have to share a right angle, an identical hypotenuse, and an identical side. And so let's try to prove that triangle ABC is congruent to triangle DCB by meeting any of these criteria. The first thing that we can notice between the two triangles is that they share the line BC. You can see that line BC is in triangle ABC, and line BC is also in the triangle DCB. And so already we've found one identical side that is shared between both triangles. Now you can see that we've labelled 60-degree angles for each angle in triangle AED. Now this is because triangle AED is an equilateral triangle, which means that every angle in triangle AED is equal to 60 degrees. Now let's see if we can work out any more angles in the triangles ABC or DCB in order to prove that the two triangles are congruent. We can use our knowledge of circle theorems to help us do this. Angle DAC and angle DBC lie in the same segments, and one of our circle theorems states that angles in the same segments are equal. And so we can say that angle DAC is equal to angle DBC because angles in the same segments are equal. We know that angle DAC is equal to 60 degrees, and so angle DBC must also be equal to 60 degrees. Now that we've found that the angle DBC is equal to 60 degrees, we can apply the same principle to angle ADB and angle ACB. We can see that angle ADB and angle ACB lie in the same segments, and we know that angles in the same segments are equal. This means that angle ADB is equal to angle ACB, and so angle ACB is equal to 60 degrees. So we've found that angle DBC is equal to 60 degrees, and angle ACB is also equal to 60 degrees. Angle DCB in blue is part of the triangle DCB, which is also highlighted in blue. And angle ACB in orange is part of the triangle ABC, which is also highlighted in orange. And so we can now see that triangle ABC and triangle DCB share an identical angle because they both contain a 60-degree angle. And so in terms of proving that the two triangles are congruent, we've found that line BC is shared by both triangles and that they share an identical angle, and so we've found a common side and a common angle. This means that the 2 criteria that we can use to prove that triangle ABC is congruent to triangle DCB would be ASA or SAS. We have a side and an angle, and so we either need another identical angle to prove that they're congruent or another identical side to prove that they're congruent. We're going to find another identical side because we can prove that the line AC is equal to the line DB, and so let's prove that right now. We can see that these 2 angles are 60 degrees, which means that the third angle in this triangle, angle CEB, must also be equal to 60 degrees, because angles in a triangle add up to 180 degrees. And so if each angle in triangle ECB is equal to 60 degrees, that means that triangle ECB is an equilateral triangle. And so we can use the fact that triangle AED is equilateral and that triangle EBC is equilateral in order to prove that line AC is equivalent to line DB. We know that the line AC is equal to the line AE plus the line EC. Now the line AE would have to be equivalent to the line DE because every side in triangle AED is equal. And we also know that the line EB is equivalent to the line EC, because every line in triangle EBC is equal. And so what we've said so far is that the line AC is equal to AE plus EC. But because AE is equivalent to DE, and EC is equivalent to EB, we can say that AE plus EC is equivalent to DE plus EB. Now looking at our diagram, DE plus EB is equivalent to the line DB. And so using this, we've shown that the line AC is equal to the line DB. And so we can now see that we've proven that triangle ABC is congruent to triangle DCB because they share an equivalent side, an equivalent angle, and another equivalent side. And so we can see that triangle ABC is congruent to triangle DCB because they meet the SAS criteria. Now this question is worth 4 marks. We get the first mark for identifying that line BC is shared by both triangles. We get the second mark for finding that angle DAC is equal to angle DBC because angles in the same segment are equal, or for finding that angle ADB is equal to angle ACB because angles in the same segments are equal. We get the third mark for using that information in order to find that angle ACB is equivalent to angle DBC. And we get the fourth and final mark for finding that line AC is equal to line DB, and for therefore concluding that triangle ABC is congruent to triangle DCB because they meet the SAS criteria for congruency, allowing us to get the full 4 marks needed in this question.